Hello everyone. Today I would like to discuss about loop control statement in C language. In fact, in previous sessions we have seen selection or decision control statement followed by the case control statements. Today I would like to talk about the loop control statement. In fact, in C language there are three loops. One is while, do while and for loop. In the next session, I am going to talk about the for loop and nested loops. In the today's tutorial, I would like to discuss about the while loop and also I also comment on do while statement. So let us go uh, with the while statement, and you can see on screen. So in fact, in programming, what happens in the selection or decision control statements, we have witnessed if statement is available. If condition is true, we would like to execute a block of statements. That's what we have seen with if statement. So we are going to execute a block of statements, right? So the limitation with this if statement is, for example, if condition is true, the block of statements are going to be executed only one time. Only one time execution happens. So then the control comes out of the block and you will execute the rest of the statements. Am I right? Fine. But there are situations where you would like to execute a certain set of statements. Say, I would like to execute one block of statements, say n times. So I would like to execute this block of statements n times. Then the if statement is helpless for us. In such case, we go with this loop control statements in C language. So you can see on screen. So we have three loops. In fact, one is while, do while, and for loop. Right. So let us look at the while loop initially. You can see you can write the test condition with the keyword while. Right. While test condition is true, you are going to execute the statements here. So if test condition is true, you are going to execute this block of statements. And this is in fact it is a loop. So when you execute the block inside this while statement, again you goes back and you will test the condition again. Still, if the test condition is true, you execute again the block inside the while, otherwise you will come out of the loop. So the point is, if you really want to use this, so because you are testing the test condition, so before you test the condition, so we have to initialize the variables which are participating in the test conditions. Initialization, we call it as initialization, and then we write the while loop. You will have test condition tc and try to execute this block of statement, and you are going to update the variables participating, variable, single variable, or variables participating in the test condition. Variables participating in the test condition. Then you close the loop. So this probably, in fact, in programs you may do the increment on variable I, or you may reduce the n value, say let it be n by 10, so on. So you will be updating the variables participating in the expression that as written as part of the test condition of the while loop. Okay, guys. So let us look at various programs or real-time problems that can be solved using the simple while loop. So in fact, in the present session, so I would like to cover top 10 programs. So I request the students to uh, attend this session. Uh, if you attend this session with sincerity and commitment, and if you could able to address these problems using the simple while loop, probably later on you can write the programs or you can address the various problems using the loop control statements. So I am going to address all these problems in the today's tutorial. So let us see one after another. The first program that was listed here is I would like to print the sum of the n natural numbers. So normally we represent the natural numbers with n, and the natural numbers are can be represented as 1, 2 positive integers. Okay, so on all are natural numbers. So I would like to do this sum. How can I do that? In fact, we have the mathematical formula. In fact, to find the sum of the n natural numbers, so we say n into n plus 1 by 2. So where n is the last term in the series. But I am not going to use this formula, but I would like to use the loop to find out the sum. So what I will do is initially for addressing this problem, I will test the n value. If n is say less than or equal to 0, in fact we won't do sum. Okay, so if n less than 0 means let us see program will print that enter, let it be enter positive value for n. Am I right? Positive value. Else what I will do is I am going to do this sum of the n natural numbers. So how can I do that? So in the else part, probably, so how can I do is let my sum initial will be assigned as 0, and in fact the sum has to be, okay, so the sum of all these natural numbers. So somehow I have to write the logic that has to be 1 plus 2 plus 4 plus 5 plus 6 so on up to n. That should be the logic. So let us see the flowchart for the first program. Later on we will look at the rest of the problems. You see, I have initialized sum as 0, and if n less than 1, in fact less than 1 means if n is equal to 0 or negative, so just I am printing the sum because sum is initialized to 0. You can also write let us enter the positive value for the n. So otherwise what I am doing is, so I am going to implement the while loop. So you can see the arrow here is simply while statement. So what is this represent is, so while I less than or equal to n, that would be my test condition. So this is the test condition. So what I have to do is I have to add all the numbers. So where should start I value? So I value I just initialize. Initially I take sum is equal to 0, and I initialize I value as 1 because we start from 1. So what should be the case? In fact my sum has to reflect all these. 1 plus 2 plus 3 plus so on. Am I right? So if I look at the series 1 plus 2 plus 3 plus 4, so I can initialize this I with 1 initially, and next let me increment this value I plus plus. So what I can do is, yeah, let me I can write sum is equal to, let it be sum plus I. So initially when I is equal to 1, so my sum will be, when I is equal to 1, sum will be 1. Fine. If I becomes 2 means, so I have to add this 1 plus 2. So what I will do is, so I will be again doing this sum is equal to sum plus I. Then what happens? So sum is updated now, sum is equal to 1. In fact, then sum becomes 1 plus 2, it becomes 3. And when I is equal to 3, again, so I will increment the I value each time. So the same statement is executed again. So what happens? Now the sum is 3, sum is equal to 3 plus 3, then sum becomes 6. So that way I will be incrementing the I value and calculating the sum is assigned, sum is updated. So this sum is equal to sum plus I am going to keep in a, I am going to keep this statement in a loop. Right? Let us look at the program. You can see. So I have written, see, I have scanned the n value. If n is equal to 0, so you can see, let me take red color. Yeah, so just I am printing the sum, right? Else, until while I less than or equal to n, so I is already initialized with 1, and n value you enter n is equal, let it be 5. So you entered n values. So what I am doing here is I am performing sum is equal to, in fact, sum plus I. So I have used the postfix incrementation for the I. It could be written as like I plus plus. So because being it is in the loop, yeah, okay, so these two statements within this while, so I am doing this sum is equal to sum plus I. So sum is, this is the only single statement, so I have not written the open curly brace and closed curly brace, fine. And when I come out of the loop, I am going to print this sum, so that way you can calculate. So if I is equal to say 1 and say n is equal to 5, what happens? Fine, initially, okay, imagine the step number 1, what happens? So I less than n means yes, 1 less than or equal to 5, it is true, sum is updated, sum becomes sum plus I. What does it mean? Sum becomes 1 and I gets incremented, so then I becomes 2. And now again you goes back the loop, and 2 less than or equal to 5, yes or no, it is true, sum gets updated, sum is equal to sum plus I, sum updated value of sum is now 1, so this becomes 1 plus 2, sum becomes 3, and now I becomes 3, fine, again goes back, check the condition, I less than or equal to 5, yes, 3 less than or equal to 5, it is true, sum gets updated, sum becomes 6, and I is equal to 4, again, yeah, so 4 less than or equal to 5, it is true, now sum is equal to updated, 6 plus 4, it becomes 10, and I is equal to 5, it becomes 15, and I is equal to 6, then is 6 less than or equal to 5, it is true, no, false, then we will come out of the loop and we will print the sum. So that way we will write the solution to this problem, right? So let me move on to the other problem, that is how to print the factorial of a given number. In fact, so if say if n is equal to 3, the problem is we have to get the 3 factorial. So what is the value of 3 factorial? In mathematics we write it as 1 into 2 into 3. So earlier problem is, this problem is both are same. So earlier problem is we have done 1 plus 2 plus 3, that is sum. Now this is only thing is that we are going to replace this plus with star. The rest of the problem is same. So I am going to replace this plus with star. You can see now I have written as here fact is equal to so fact star I plus plus. You can decode this optimized statement as like this. But only the difference is we have to initialize the fact as 1. In the earlier problem we did sum is equal to 0. I cannot say fact is equal to 0. Why? Because if you say fact is equal to 0, 0 multiplied by anything becomes 0. The complete the expression evaluated to be 0. So that is the reason why make sure that fact is initialized with 1. And one more thing is if n is equal to 0 or n is equal to 1, we need not write any logic, because the 0 factorial or 1 factorial is 1 in mathematics. Right away you can print. So I am printing directly the factorial value. In fact, I have taken this factorial as a long int, fact as a long int. Why? Because so if you take this fact as int variable, so if you calculate the 10 factorial, probably the value that you will get may not fit into memory allocated for this integer, because the 4 bytes of memory may not fit into the memory, and that is the reason why I have taken long int. Probably the long int could handle up to 19 factorial. You can check it out. So memory is more enough to represent up to 19 factorial. So that way you can address this. And let us look at the other problem. You can see I would like to find the largest marks and second largest marks of the n students. So there are, see, in class there are 5 students. If say n is equal to 5, and for example in problem solving through C language, the marks obtained by the students, let it be 85, 75, 60, 45, say 90. These are the marks obtained by the students. So I would like to print the largest and second largest. In fact, I take it as max 1 and max 2. The output of the program max 1 must be 90 and max 2 must be 85. Alright, you can see on screen. So how can I do that? In fact, so when you start writing the solutions to the various problems, you will get an idea. So directly probably you may not get an idea, but the moment when you start practicing various problems, so you will get idea how to implement this. So what I will do is I will initialize the max 1 as 0 initially, and max 2 is declared okay, as integer variable, or you can take it as a float variable. So what I will do is I start scanning the marks. So because I have students, 5 students with me, so I have to scan the marks of the 5 students. So when I scan the marks, I simply dump these marks into a variable named as marks. Okay, I will compare these marks first when I scan the marks. So what happens? 85 will be the first marks that are given here. So this 85 is compared with is 85 is greater than max 1? Yes, absolutely it is true. So I will assign this, I will update this max 1 as 85 because max 1 is taken initially as 0. Before, prior to this, what I will do is I will update max 2. So prior to this max 2, I will write it as max 1. Then now let us look at this situation. So max 1 becomes 85 and max 2 becomes 0. Fine. So when I get the next marks will be compared with again this max 1. So what is that? 85 is greater than, 75 is the next mark. So 75 is greater than 85? No, false. So then what I have to do is I have to update the max 2. So 75, in fact it is false. But what happens? 75 is greater than max 2. Of course 75 is less than max 1, it is max 2. So I have to update the max 2 then. So what I will do is I will update max 2 as marks, current marks. So what happens after executing this? So you will get max 1 as 85 and max 2 as 75. The process is repeated till you read the last mark of the student. You can see on screen. So let me scan the number of students. Okay. Later on I start scanning the marks. I have declared the variables as real variables. So I started scanning the marks. When I scan the marks, I will just compare these marks. So I said earlier it is 85 is being compared is greater than 0. Yes, absolutely. So I update the max 2. So then max 2 becomes 0 and max 1 becomes 85. Am I right? Fine. So in fact this will be executed first time. So next the marks are 75. So 75 is compared with, again because I am in the loop, 75 is compared with marks. So if condition is false, I come to else. So mark 75, now it is greater than max 2 is 0, I will update this max 2. Now my max 2 becomes 75. And the loop gets repeated for the rest of the values. So you will be updating the max 1 and max 2 continuously till you obtain the maximum marks of the maximum marks into max 1 and the next maximum into max 2. So I wish it's okay with you. And let me talk about the other program. I would like to find out whether the number is prime or not. So the input for the program is simply we will give the n value. Input is n value, right? Fine. So whether the number is prime or not, how do you find whether number is prime or not? In fact, what we will do is say if number is 11, so we will divide this number 7 with the numbers between 1 and 11. Am I right? So we start from 1 and 2, so on, 3. That is the process, in fact, am I right, up to 11. So we know that number is divisible by, every number is divisible by 1 and itself. So if the number is divisible by only 1 and itself, then I can say it is a prime number. Otherwise, it is not a prime number. So I start dividing this. So because I know that the number is divisible by 1, okay, so 11 percentile 1, I will divide this. If the remainder is 0, in fact, that is divisible. If remainder is not 0, that is not divisible. So what I will do is up to, I will do 11 percentile 2, whether let me check it, 11 percentile 3, so on up to 11 percentile 11. So in fact, every number is divisible by 1. So what I will do is, yeah, whether the number is divisible by 1 and number is divisible by number itself. In fact, 11 percentile 11 is equal to also 0. So both these cases, so we know that the number is divisible. So in fact, that can be considered as, you can take one variable to come to know that the number is divisible by only 1 and itself. But in mathematics, we have other logic also. Mostly you might be knowing any number, if you are dividing this, say x, if x exceeds more than half of the magnitude of the number, so no number divides the x. So in fact, you need not to divide each number between 1 and n, but if you can continue the loop only up to 1 to n by 2, that is also more enough. So the logic is, if the number is 100, so the numbers between 15, 1 to 99, no number divides. So 100. It's very simple logic. If the number magnitude exceeds more than the half of the number, those numbers will never divide the actual number. So that is the reason why I kept loop here only up to I less than or equal to n by 2. I repeat. Because I am starting with 1, I is equal to 1. You can see. We come to know that every number is divisible by 1. So initially I have taken count is equal to 0. Now I am incrementing this as count plus plus. Means your count becomes count plus 1. Means I said the number is divisible by only 1. So then each time the count is updated as 1. Count is updated as 1. But for the rest of the numbers, you can see, then I is incremented. So I becomes 2. So again the loop gets repeated. Okay. Fine. Again we will check this condition. If n percentile I is equal to 0. Means if count is more than 1. Means apart from the 1, some other number will be dividing this. Am I right? In such case, so it is not a prime number. So I would like to terminate the loop. So for example, if number is, say number is 4, see, then we will start with 1, 4 percentile 1, it is true. And I say 4 percentile 2, it is also true. Means because the number is being divisible by 2, there itself I can conclude that 4 is not a prime number. So I will break the loop and come out of the loop. And I will check whether the count is only 1 or not. If count is more than 1, it is not a prime. In fact, in the worst case, we will come out of the loop in 3 cases. In 2 cases. One is if I greater than n by 2, we will come out of the loop. Or because of the break, we will come out of the loop. So for which condition we just came out of the loop, we have to note it down. That is the reason why normally we prefer to take a variable inside the loop that will monitor the condition or the outcome of a condition. So I have taken here as a count variable. So if count is only 1, then I say it is a prime. If count is more than 1, means some number is dividing this number. So it is not a prime number. Okay guys, I wish you could able to understand this. Yeah, so next is I would like to find out the GCD and LCM of two numbers. All these programs you can perform with either while, do while or for loop also. But these programs are well suited if you could write the solution using the while statement. Am I right? So I would like to find out the GCD of two numbers. For example, say let me take uh, two numbers, say A is equal to 12 and B is equal to 18. So how do I find the GCD? What is GCD, greatest common divisor? So I can see the greatest common divisor for these numbers. I can write it is a, in fact it is a 6. Am I right? Right. So you can do why or one thing you can do is I start dividing these numbers starting from 1. So see 1 2, I can go up to 12. So 1 2 3 so on, I can go up to 12 to find the common factor, but there may be more than one common factor for this 12 and 18. So remembering that if the concept is of array, if you know, you just keep on these reminders or the numbers, okay, all in single array, and the last element of the array could be the GCD of the two numbers. Instead of that, what I can do is I can start with the minimum number. So I start among this A and B. Minimum is say 12. Now I start dividing this A percentile minimum is equal to 0, and B percentile minimum also if is equal to 0, I can say minimum is the GCD, right? Because I'm coming from the end of the minimum number. So if minimum divides, otherwise what happens, I will decrement this minimum. Am I right? I will decrement this minimum. That would be the logic of the program. You can see. Yeah. So to find out this minimum among the two numbers, I have taken this conditional operator. So minimum will have the minimum number. So how long I have to decrement this value till up to, because in the worst case, what would be the GCD of given two numbers? Means for example, say if 9 and say 21 are taken, so the GCD of these two numbers will be only one. I start from 9 and yeah, decrement 8, 7, 6, so on. I will repeat this series up to 1 only. Fine. So what I have done is, yeah, if, the minimum is dividing both the numbers, so you just break the loop and come out, and you print the minimum as the GCD. Or else you subtract this, decrement this minimum and go back to the loop and do the same. Now, of course, LCM of two numbers, see in mathematics we write. So if numbers are n1 and n2, LCM is n1 by n2 by GCD. So this is the LCM logic. So there is other way of doing LCM also. I request the students to go through it in the similar way. To find out the LCM, we start with maximum, in fact, rather than minimum. Yeah, you can see I would like to find out the sum of the individual digits of a given number here. So the number, say you can see n is equal to say 123. I would like to find the sum. So what would be the sum of the individual digits of the given number? 1 plus 2 plus 3. Am I right? That is 6. How can I do that? So what I can do is, every time I would like to separate the last digit of this number. So last digit of any number you can obtain using modular division operation. That could be n percentile 10. So then the last digit of this will be the remainder. So remainder is 3. And then this, if the number becomes 12, so same logic can be used to separate this 2 from the number. Later on this number should be 1, so I can separate the number. So for that, so I want now 123 to be 12. So then you have to update the n value. Let it be n value would be n by 10. So that way your 123 becomes 12. Am I right? Because n is equal to n by 10 will return the quotient of the operation. So modular division returns the remainder of the operation. This can be done till your n value becomes 0. If n is equal to 0, you just stop the loop. So that's what I am doing. So let me scan it. So while n not equal to 0, just initialize sum is equal to 0. I am doing the individual digit sum and update the n value. So this loop is being repeated up to some point of time. So n becomes 1. For example, say this 1 by 10 becomes 0. Am I right? Or 2 by 10 or any digit, most significant bit of the number when you come to that. So if you divide that, it becomes 0. So then you will print the sum. So some cases it may be asked if the sum of the, yeah, yes, fine. So that way you can calculate the individual digits of a given number. Yeah, whether number is Armstrong or not, it is also quite simple. So see, what is Armstrong number? So in fact, if the individual sum of the cubes of the individual numbers means 1 cube plus 5 cube plus 3 cube, if it is equal to say n, then we say it is a Armstrong number. So far we have done already the sum of the digits of a given number. Only thing is that instead of adding the just sum, I would like to apply the cube. So let me separate the last digit and I am performing here. So it could be like if n is equal to n percentile 10 or x is equal to n percentile 10. So I have to write sum is equal to simply sum plus x cube. So in programming this x cube, we have function inbuilt function named as power. So to apply this, you have to include the math.h. If you are really executing this program on GCD, so simply write cc filename.c. Okay, say f1.c hyphen lm to link mathematical directory. Okay, otherwise probably you could not able to do that. So fine. Yeah, so that way you can print each time the sum. In fact, need not to write the statement. So when you come out of this loop, so because I would like to check whether the sum and the given number is equal, but the number is being modified because I am updating the n value, and in fact n becomes 0. So that's why before prior to loop you have to assign this n value to some temporary variable, that you have to remember. So this way you can calculate. Yeah, we have seen whether the number is prime or not, but I would like to find out whether number is perfect number or not. For example, if I say n is equal to 6, what is perfect number? If the sum of the factors of this number is equal to the same number, so 1 is a factor, 2 is a factor, 3 is a factor, 6 is a factor, but we exclude the number itself. So by excluding the number itself, the sum of the factors of the given number, let me do 1 plus 2 plus 3 is equal to 6. Now 6 is a perfect number. Am I right? 6 is a perfect number. In fact, 28 is a perfect number. So only thing is that you find out all the factors for the given number. Earlier we have seen if count is equal to 1, we said it is a prime number. Otherwise it is not. But this time we just divide, and if it is a factor, you add up it to the sum. So what I am doing is, yeah, it is same logic applied for the prime number. We also apply. So up to, because factors we come to know that only up to n by 2 factors will be there. So if divides, let me update the sum as sum is plus I. And when you come out of the loop, let me check it whether this is equal to the sum or not. So that way we can do. Now I would like to print the Fibonacci series. Probably guys, what is Fibonacci series? Is in fact, yeah, it is a series in which first two terms are 0, comma 1, and rest of the terms or third terms onwards, they are found as sum of the preceded two terms. Means this next term will be 1 plus 2 3, 2 plus 3 5, and 5 plus 3 8, 8 plus 5 plus 8 13, so on. So it is a series in which first two terms are 0 comma 1, or yeah, it could be like 0 comma 1, and third term onwards or third term onwards will be found as sum of the preceded two terms. In fact, if two terms are a comma b, and the third term onwards will be a plus b will be continued. Okay, this will be continued. So that's what. So to do this program, what need to be done is, we come to know that first two terms are 0 comma 1. So I have taken them as a comma b, and a comma b initially printed means 0 comma 1 is printed. So if the program says there we need n terms to be printed, so already two terms are printed, your n becomes n minus 2 because two terms are already printed. So that's why I'm taking the loop, this loop, as I less than or equal to n minus 2. So I said third term onwards it is c is equal to a plus b. So I have done c is equal to a plus b. So what happens, initially 0 and 1 is printed. Then I am printing c. My c is actually 1. But what happens the next time? Next time what happens? This is a and this is b. Now this is c. The next term we will be getting 2. So to get this 2, so I have to move this position of a to b, and the position of B to C, means then what happens is your A becomes 1 and B becomes 1, then only your C is equal to A plus B becomes 2. So that is the reason why equal to A plus B, that becomes 2. That is the reason why I am updating the A value, moving this to the right. A is updated as B and B is updated as C. Now what happens initially for when I is equal to 1, so your A is equal to B means A becomes 1 and B is equal to C means now C is been rightly calculated. The value of C is 0 plus 1, it is 1. Now B is updated. The same is repeated till we reach the I value up to n minus 2, means n terms will be printed. So guys, yeah, so let me discuss about the do while loop also. In fact, the do while we use it very rarely, but what is the difference you can see is in do while we don't test the condition first. So the condition is being tested at the end of the loop. So this is the body of the loop gets executed first. So we execute the body of the loop first, then we test the condition in fact. So you can see here, yeah, so in while loop we are simply testing the condition first and executing the statements, right? In do while loop we are executing the statements first. That's what the difference is. Let me take another color. Yeah, you can see. So we take in fact we execute this body of the loop and increment or decrement the variable and we test the condition at the end of the loop. This is the syntax. So what is the difference here is you can see I is equal to 0. Is I greater than 0? No, false. So we won't enter into the loop. So don't enters the loop. But here I is equal to 0. What is the what happens? So simply we enter into the loop, we print the 0. And now I is decremented, so I becomes minus 1. Now we will test the condition. Is minus 1 is greater than 0? No, false. So we will come out of the loop. But meanwhile what has been happened is 0 is being printed. So there are situations where this do while loop is used in fact. So when you go to the restaurant, so you consume the food first, later on you will be asked to pay the fees. That time you may have the purse with you, you may forget the purse, then the different story. Even it is like Indian Railways, you can board the train at any point of time without railway ticket with you. When TC comes, then only you will check the ticket. But whereas in RTC, so you have to show the ticket the moment when you step into the bus. So that is while loop, and railway reservation or the railway ticket is do while loop. You can. There are situations, in fact, the data structures. This do while loop is very useful when you are implementing the linked list concept, because sometimes so the last node of the linked list, in fact, say you have the element 10. If it is last node, the last node pointer will be null. So the pointer is, though it is null, I would like to print the value of the node. In such case you feel the do while loop is essential. So in fact, let us see one example program on do while loop. You can see here. So I would like to print the sum of the numbers being entered by the user till he enters the 0. It is not the same as like sum of the natural numbers. So I would like to find the sum of the numbers. So you will enter numbers randomly, 2, say 15, 50. If you enter minus 1 or 0, let it be the 0, then I will stop the process. So what I am doing is I have taken do while loop, you can see. Okay, fine. And this is the syntax of the do while loop. So how long this loop is repeated? Till the number entered by the user is 0. If it is 0, simply we will come out of the loop. However, if initially it is 0, we won't come, we will execute. So you will be entering. So what I am doing is when he is entering the number, I am updating the sum as sum plus the number being entered over there. So this process is repeated. In fact, this process is repeated until user enters the 0. So if enters the 0, otherwise what happens is sum becomes 10 plus 20 plus 15 plus 50. Am I right? What is the sum value? 30 plus 65, maybe 95. because this sometimes if you forgot to enter the 0, then it becomes infinite loop. So either while or do while, how do you form the infinite loops? If you say while one, if you do something, so this is the infinite loop. Even with the do while also same. If you write do while and while one, it becomes infinite. Sometimes you may get a peculiar situations where people will write while one, and this becomes also infinite loop. Whatever you do, normally we don't enter into this block, so you will be executing the semicolon infinite times if you write semicolon at the end of the loop. And people often will forget incrementing the I value while I less than or equal to n. Say initially I is equal to 0 and you want to do something, but you don't update the I value. So what happens? So I is always 0, the loop gets repeated infinity times. So don't forget to increment or decrement the values or variable increment or decrement variables participating in the test condition. So these are the very essential points everybody has to note when you are really practicing the while loop. In fact, you can write while inside the another while also. Next we call it as a nested loop. Fine, you can write one more while also. We are going to see the concept of nested loops using for loop, because for loop is quite flexible and convenient to write one for loop inside the another for loop rather than using the while inside the while. So coming tutorial I am going to discuss about the nested loops, and we will see different real-time problems that can be solved using the nested for loop in the next tutorial. That's it from my side, guys.